In this video, we're going to see using the quantitative bias test module within a submission on the Luminos.ai platform. So we've created our submission based on one of our standard forms, and we're in the process of filling out that submission. I'm logged in as a data scientist user or one of the other team members who's involved in the project. And I'm filling out information in a lot of these text response forms. But here we have a quantitative bias test module. So this is a module that will accept a CSV file of output data and demographic labels from the AI model in question, and will conduct a battery of statistical tests to evaluate whether there is bias present in the behavior or the output of that model against various protected demographics or any other characteristics you select. So we are going to simply choose a file that contains the model output. For our first pass, I'm going to run a batch of data that I know will fail. And as soon as we upload that file, the data is parsed, and we'll see we have a couple selections to make to run the tester. We need to tell the tester the type of output. In this case, this is a binary decision model, so that it has discrete outcomes, basically pass or fail. We need to tell it where the model output is stored. In this case, it's in the field match score, which the fields were detected by the bias tester. So it already looked at the headers and gave us the correct pick lists. And the variable for the ground truth, or the comparison for accuracy, is the admit field. So those are the primary selections I need to make. And then in terms of the bias testing itself, I need to identify which of the fields from the header are gender or race or age or disability, or other protected characteristics we want to test against. So we'll select male and female for gender. We'll select white, Asian, and Hispanic and black for our races. Again, as I'm logged in as the data scientist, I'm familiar with this data set, so I know what the fields are. In this case, they're pretty clearly labeled. And then finally, all we need to do is select a control group. And so we're going to have the white males be our baseline, and we'll evaluate the performance of this model as a baseline against that demographic. Once I've done those things, I just need to run the bias analysis. It will take a couple minutes to run, or a couple of seconds to run behind the scenes. And then we'll see an output. And our output will contain both numerical results and formatted tables with guidance as to the expected performance, and quite a bit of detailed plain English language and legal English language descriptions of both the contents and the results. So scroll down here and we'll see it. Color coding is as you'd imagine. The dark green are the performance items that are right where we want them. The light greens are acceptable but maybe borderline. The red highlighted items are things that we should probably review more closely, typically because performance is below the expected performance. So for example, in this case, our racial demographic comparison of white versus Hispanic, some of these performance items in red have a lower performance than we want. And the purple ones actually favor the protected group, but they're still outside the ideal range, so they may also warrant scrutiny. So you can see we've run bias tests against all of our different demographic comparisons. Our gender bias looks really good. This model is producing unbiased results for the selected decision against male versus female. But in our racial bias, it looks like we still have some work to do. Now, the tests in the full version of the bias testing module, if you run all of the tests, we have a number of different evaluations, and all of these are drawn from different legally based guidelines. So in this case, this binomial Z-Fisher's test is from the Office of Federal Contract Compliance Programs. We have percentage difference tests. We have the adverse impact ratio, which is a popular one. And you can see this is a good example. In the adverse impact ratio test, we have borderline results for those standards. The typical result standards are explained, 0.8 to 1.25, but also Luminos.ai, and our partner Luminos.law has quite a bit of experience in all these spaces, and we have legally based recommendations about what we should be achieving, in this case 0.9 and 1.1. And we have plain English explanations of what all these fancy numbers mean. For every 1,000 white candidates who had a positive outcome from this model, 825 Asian candidates had a positive outcome, which is a as you can see, somewhat of a deficit, and worse than the gender balance that we see between male and female candidates. So this report was generated dynamically, including the actual statistical population testing that was run from the raw data that we just uploaded. And it is very thoroughly documented and footnoted and ready to be turned into a legal report. But of course, we're not satisfied with some of these performance items here. And so we're going to go back and we're going to run a second test after we have tuned up our AI model to have some slightly different characteristics. So perhaps we are going to change the representativeness of the input training data, or perhaps we're going to tune the hyperparameters, but we're going to do our best to get this model to be as unbiased as possible. Once I've done that, I can come back to this submission, I can upload a new set of data and simply run it again. All of our characteristics are the same, so we don't need to select them again. We're just going to run this model a second time. While that's running, we can see in this form, there are entry fields for remediation methods and comments on the results. Again, your organization can design the form to have whatever fields you want, whatever process to handle once you get the results in place. But there are some best practices baked into a lot of the forms you'll get out of the box. And now that our bias analysis has run a second time, you can see we're green across the board. We've done a pretty good job remediating our model. Improving the training data has resulted in it treating protected groups much more even-handedly compared with our baseline group. And so with that, we're pretty happy with this. We're going to go ahead and sign this document as ready for review and return it back to the reviewers.